This is SpaceTime Series 27, Episode 44, for broadcast on the 10th of April 2024. Coming up on SpaceTime, new clues about Mars's ancient water, NASA's new moon buggies, and the largest digital camera ever built for astronomy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover has arrived at an area in Gale Crater's Mount Sharp that may be showing evidence of liquid water having flowed on the red planet for much longer than previously thought. The six-wheeled car-sized mobile laboratory has begun exploring a new region of Mars, one that may reveal more about when liquid water disappeared once and for all from the red planet's surface. We know that billions of years ago, Mars was a much warmer and wetter world. Curiosity is getting a new look into that more Earth-like past as it drives along and will eventually cross the Geddes-Valles Channel, a winding snake-like feature that, from space at least, appears to have been carved out by an ancient river. And that possibility has scientists intrigued. The rover team are looking for evidence that would confirm how the channel was carved into the underlying bedrock. In fact, the formation sides are steep enough that the team doesn't think the channel could have been made by wind. However, debris flows, that is rapid wet landslides, or even a river carrying rocks and sediment along with it, would have had enough energy to chisel into the bedrock. After the channel was formed, it was then filled with boulders and other debris. Scientists are also eager to find out whether this material was transported by debris flows or by dry avalanches. Since 2014, Curiosity's been ascending the foothills of Mount Sharp, a 5-kilometre high central peak in the middle of Gale Crater. Mount Sharp contains many different geological layers. That's why Curiosity's there. Because reading those layers is like reading a geology book on the history of Mars, or at least the history of the Gale Crater region. The layers in the lower part of the mountain formed over millions of years amid a changing Martian climate, providing scientists with a way to study how the presence of both water and the chemical ingredients required for life may have changed over time. For example, a lower part of the foothills include a layer rich in clay minerals, where a lot of water once interacted with rock. Now, however, the rover is exploring a different layer, one enriched with sulfates. These are salty minerals often formed as water evaporates. It'll take months to fully explore the channel, and what scientists learn could revise the timeline for the mountain's formation. Once the sedimentary layers for lower Mount Sharp were deposited by wind and water, erosion whittled them down to expose the layers' visibility today. Only after these lengthy processes, as well as intensely dry periods during which the surface of Mount Sharp was a sandy desert, could the Geddes-Valles Channel have been formed. Scientists think the boulders and other debris that subsequently filled the channel came from high up on the mountainside, elevations where Curiosity would never be able to reach. And so by studying this debris, it'll give mission managers a glimpse of what kinds of materials may be lying up there. Curiosity project scientist Ashwin Vasavada from NASA's Jet Propulsion Laboratory in Pasadena, California, says that if the channel or the debris piles were formed by liquid water, it would mean that fairly late in the story of Mount Sharp, after a long dry period, water came back, and in a big way. And that explanation would be consistent with one of the most surprising discoveries that Curiosity's made while driving up Mount Sharp. Water seems to have come and gone in phases, rather than gradually disappearing as the planet grew drier. These wet and dry cycles can be seen in evidence of mud cracks, shallow salty lakes, and directly below the channel, cataclysmic debris flows that piled up to create the sprawling Geddes-Valles Ridge. Last year, Curiosity made a challenging ascent to study the ridge, which sort of drapes over the slopes of Mount Sharp and seems to grow out of the end of the channel, suggesting that both were once part of the same geologic system. Curiosity's now documented the channel with a 360-degree black and white panorama from the rover's left navigation camera, showing dark sands that filled one side of the channel and a debris pile rising up behind the sand. In the opposite direction is the steep slope that Curiosity climbed to reach the site. The rover takes panoramas with its navigation cameras at the end of each drive. Now the science teams have to rely on the navcams even more, while engineers continue with their efforts to try and resolve the ongoing issue, which is limiting the use of one imager belonging to the colour mass cam camera. This is SpaceTime. Still to come, NASA selected 3 companies to help develop its new moon buggies, and the largest digital camera ever built now ready for installation. All that and more still to come on SpaceTime. NASA has selected 3 companies to help it develop a proposed new moon buggy, the Lunar Terrain Vehicle, or LTV. Intuitive Machines, Lunar Outpost, and Venturi Astro Lab have been awarded $4.6 billion in contracts to develop the capabilities Artemis crews will need in a future moonmobile for transport across the lunar surface. These vehicles will not only need to provide a mobile platform for manned scientific exploration of the lunar surface, but they'll also set the stage for future manned vehicles to operate on Mars. And when it's not being used to transport astronauts around the lunar surface, it would operate remotely as a science platform. Current plans would see the first lunar terrain vehicle transported to the moon in time for the Artemis 5 mission. Each of the 3 companies will spend a year to develop specific capabilities as directed by NASA mission managers. And that'll be followed by a demonstration flight to deliver the vehicle to the lunar surface and then validate its performance and safety ahead of the Artemis 5 mission. And no, there's no word yet as to whether or not the STIG will do the testing. NASA will also issue additional task orders to provide unpressurized rover capabilities for the agency's moonwalking and scientific exploration needs through to 2039. The Lunar Terrain Vehicle will need to handle the extreme conditions of the moon's south pole. It'll feature advanced technologies for power management, autonomous driving capabilities, and state-of-the-art communications and navigation systems. Crews will use the Lunar Terrain Vehicle to explore, transport scientific equipment, and collect samples from the lunar surface much further than they could on foot, thereby enabling increased scientific returns. Now, between Artemis missions when crews are not on the moon, the Lunar Terrain Vehicle will operate remotely, undertaking scientific missions as needed. Now, outside those times, it will be made available for commercial lunar activities, unrelated to NASA missions. NASA hopes to send a 4-person crew aboard the Artemis 2 mission into orbit around the moon next year. That'll be followed by Artemis 3 in 2026, which will see humans return to the lunar surface. The Artemis 3 Orion capsule will rendezvous in cislunar orbit with a pre-positioned SpaceX Starship HLS, which will then take 2 of the crew down to the lunar surface near the South Pole, where they'll spend several days before flying back up into orbit to rendezvous with the Orion capsule for the return to Earth. The Artemis 4 mission will see an Orion capsule rendezvous with the new Lunar Gateway space station in cislunar orbit, from where crew will transfer to the SpaceX HLS for the journey down to the moon and back. From then on, Lunar Gateway will act as a jumping-off point, a sort of base camp for excursions down to the moon's surface, with the HLS and other lunar descent vehicles doing the transporting. Certainly exciting times ahead. This is SpaceTime. Still to come, the largest digital camera ever built for astronomy, and later in the science report, could volcanoes hold clues about the first building blocks of life on Earth? All that and more still to come on SpaceTime. Well, after 2 decades of work, scientists and engineers with the U.S. Department of Energy's Stanford Linear Accelerator Center's National Accelerator Laboratory have finally completed the legacy survey of Space and Time camera, the largest digital camera ever built for astronomy. As the heart of the Vera C. Rubin Observatory, the 3,200 megapixel camera will help researchers observe the universe in unprecedented detail. Over 10 years, it'll generate an enormous treasure trove of data on the southern night sky, which researchers will then mine for new insights into the universe. The data will aid in science's quest for understanding dark energy, a mysterious force which is driving the accelerating expansion of the universe and which will determine the universe's ultimate fate. It'll also hunt for dark matter, another mysterious substance which makes up about 85% of all the matter in the universe. Although it's invisible and scientists have no idea what it is, they know dark matter exists because they can see its effect on surrounding normal material, what we call baryonic matter, the things stars and planets and trees and cars and dogs and cats and people are made out of. Researchers also have plans to use the Rubin data to better understand the changing night sky, the Milky Way galaxy, and our own solar system. With the completion of this unique camera at the Stanford Linear Accelerator Center and its imminent integration with the rest of the Rubin observatory systems in Chile, scientists will soon start producing what really, when you think about it, will be the greatest movie of all time and the most informative map of the night sky ever assembled. To achieve this goal, the team have built a camera as big as a car. The 3,000-kilogram instrument has a front lens more than 1.5 meters wide. That's the largest lens ever made for this purpose. Another meter-wide lens had to be specially designed to maintain the shape and optical clarity while also sealing the vacuum chamber that houses the camera's enormous focal plane. That focal plane houses some 201 individual custom-designed CCD sensors. The pixels themselves are only 10 microns wide. The camera's most important feature will be its resolution. It'll be so high it could resolve a golf ball's dimples from around 25 kilometers away while still covering an area of the sky 7 times wider than the full moon. These images, with billions of stars and galaxies, will help unlock the secrets of the universe. Most notably, the camera will look for signs of weak gravitational lensing. This happens when massive galaxies subtly bend the pathway of light from background galaxies, causing it to refract on its way to us. Weak lensing reveals something about the distribution of mass in the universe and how that's changed over time, and that will help cosmologists better understand how dark energy is driving the expansion of the universe. Under the rules of dark energy, eventually we'll live in a dark, cold universe, where all the nearby galaxies will move so far away they'll be out of sight beyond the cosmic horizon. And so, other than the stars in our own galaxy, the universe will seem cold, dark and empty. Scientists call this the Big Freeze. A more disturbing possibility, however, is the Big Rip. You see, if dark energy gets powerful enough, not only will it cause the expansion of the universe to move all the galaxies away from each other, but it'll cause the stars in our own galaxy to move away from each other. And it will cause the planets orbiting those stars to move away from the stars. And eventually, the planets themselves will start to break up under the same force. The ultimate conclusion of this would see dark energy becoming powerful enough to even rip atoms apart, releasing quarks and gluons to float freely in space, essentially creating a big rip. But the truth is, we don't know what's going to happen yet. Scientists want to study the patterns of the distribution of galaxies and those that have changed over time, identifying clusters of dark matter and spotting supernovae, all of which will help astronomers develop a better understanding of dark matter and dark energy. And these same images will also reveal new details about distant galaxies, and that'll help researchers studying something closer to home, our own galaxy, the Milky Way. Many Milky Way stars are small and faint, but with the camera's incredible sensitivity, astronomers expect to produce a far more detailed map of our galaxy, yielding insights into its structure and evolution, as well as the nature of the stars and other objects within it. Even closer to home, astronomers are hoping to create a far more thorough census of many of the small objects in our own solar system. According to Rubin Observatory estimates, the project may increase the number of known objects in our solar system by a factor of 10. That would lead to a new understanding of how our solar system formed and perhaps even help identify threats from asteroids that could end up on trajectories taking them a bit too close to the Earth. Finally, Rubin scientists will look at how the night sky is changing. For example, how stars live and die, and how matter falls into supermassive black holes at the centers of galaxies. They're some of the ultimate big questions of science. This report from the Stanford Linear Accelerator Center.
Our story today starts in the late 1990s, when the idea for what would become the Vera C. Rubin Observatory started to emerge. At the time, researchers were looking for ways to explore dark matter. Dark matter is a substance that only interacts with ordinary matter, like the matter here on Earth, gravitationally. As researchers were trying to find new ways to explore dark matter, they made observations of supernova explosions that hinted that the expansion of the universe is actually accelerating. These observations implied the existence of a mysterious dark energy that permeates all of space. If we take all the forces that shaped the universe, scientists currently believe that the universe is made up of about 5% ordinary matter, 27% dark matter, and 68% dark energy. In this case, the term dark applies because it doesn't appear to emit, reflect, or absorb light, and scientists aren't yet sure about how to directly detect it. In order to get some more insights into dark energy and dark matter, astrophysicists realized that they would need to map out the large-scale structure of the universe and its changes over time. Where were they going to start? In 2003, Steve Kahn, an astrophysicist working on the subject, joined SLAC. He brought with him the idea that SLAC and the Department of Energy should engage in the development of a large aperture wide-field telescope that could probe at the very nature of dark energy and dark matter. Along with his fellow researchers, Kahn spent the next decade building out an international network of scientists and researchers to begin working on how they could bring the telescope to life. While the telescope itself is being built in Chile, the centerpiece camera module is being assembled right here at SLAC, using parts developed at SLAC and at other institutions around the world. The coordinated effort it took to bring together so many widespread teams was an enormous feat. The centerpiece of the telescope would be its camera module. In the early 2010s, after all their preparation, SLAC researchers and their collaborators in the US and in Europe began prototyping the camera. The camera was designed with a sensor of 3,200 megapixels, making it the largest camera ever built for astronomy. For comparison, the smartphone has around 12 megapixels. Using this powerful new camera, researchers plan to capture one image every 30 seconds. Now, I know that may not sound very fast, but remember they're photographing into deep darkness. They need a longer shutter speed for this. Once they have all these images, scientists will produce a very high-resolution image of the southern sky every 3 nights. Ultimately, the plan is to run it as a 10-year project. That means that over the course of those 10 years, the camera will capture the entire southern sky over 1,000 times. This process will create a detailed map of the night sky, revealing how matter is distributed throughout the universe, as well as charting changes in the sky and matter over time. These observations will help researchers understand the nature of dark matter and dark energy. But that's not all. The telescope and its camera will help astronomers map out a lot of transient phenomena, like exploding stars and asteroids whose positions change from night to night. A helpful way to think of it is kind of like a 10-year-long movie of the universe. This 10-year survey is called the Legacy Survey of Space and Time, or LSST, and the camera module itself has come to be known as the LSST camera. In order to design electronics for the new detectors, LSST camera researchers collaborated with teams at SLAC and at the Department of Energy's Brookhaven National Lab. They also worked closely with the Department of Energy's Lawrence Livermore National Lab to develop some of the largest camera lenses ever built. Now, after 2 decades of work, the LSST camera is complete. Then, it'll be shipped to Chile and finally ready to take the most detailed images of the night sky ever produced. Over its 10-year run, the LSST camera and the Vera Rubin Observatory are going to have a huge impact on the field of astronomy by cataloging roughly 20 billion galaxies. That's around 10% of all galaxies estimated to exist in our observable universe. And no one knows for sure what we'll discover, but it's a really exciting time for astronomy.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that high blood pressure has been the leading risk factor for death in Australia for the past 3 decades. A report in the journal PLOS ONE used data from the Global Burden of Disease study between 1990 and 2019, finding that high blood pressure persisted as the leading risk factor for both cardiovascular disease deaths and for deaths from any other cause. Dietary factors and tobacco use rounded out the top 3 risk factors. The authors warned that blood pressure control rates in Australia lag well behind many other high-income countries, and their findings support actions to improve the prevention, detection, treatment and control of raised blood pressure. A new study combining genetic, paleoecological and archaeological evidence has shown that the Persian Plateau was a pivotal geographic location, serving as a hub for Homo sapiens during the early stages of their migration out of Africa. The findings, reported in the journal Nature Communications, highlights the period between 70,000 and 45,000 years ago when human populations did not uniformly spread across Eurasia. The findings help fill a gap in science's understanding of Homo sapiens' whereabouts during this period of time. Volcanoes may hold clues as to how the first building blocks of life may have formed into complex chemical mixtures. The hypothesis, reported in the journal Nature, is based on laboratory experiments which found that heat flows moving through cracks in rocks can purify molecules relevant to the chemical origins of life. The study's authors used specially built chambers with minuscule cracks in them to isolate and purify specific molecules necessary for building life. Now, similar cracks can be found in the Earth's crust and are thought to have been abundant on Earth before life formed. Well, it seems tech giant Google is facing more controversy. With the details, we're joined by technology editor Alex Hauer-Voigt from TechAdvice.life.
Yeah, there was a lawsuit, a class action lawsuit in 2020 over the privacy controls that were built into Google Chrome. And there was the accusation that Google was tracking people when they were using incognito mode, which of course is meant to be private. And Google actually settled with the plaintiffs back in December last year, but the details only became public in the last week or so. And although they don't have to pay any damages, they have to delete the records of 136 million Chrome users, the Chrome browser users, but only in the US that I can see. So that means there are, potentially billions more Chrome users whose surfing habits have been surveilled, and that could be things you've searched for. And, Google is saying, look, we never identified anybody specifically, and Google has said we never associate the data with users when they use incognito mode. They say we are happy to delete old technical data that was never associated with an individual and was never used for any form of personalization.
Isn't that the same sort of excuse Cambridge Analytica were using?
Yeah, look, it's the same sort of excuse. I mean, the number one thing to do when you're on the internet is to use both an ad blocker. I use something called One Blocker on my Mac, iPhone and iPad. It's a paid service, but there are free ones. Ghostery but Ghostery has been accused of allowing ads that it deems to be good. There's a thing called uBlock Origin, which works on Android phones and Chrome browsers, and that's meant to be totally open source. In fact, on my website, I have links to the various alternatives to Ghostery, but Ghostery is good as well. Ghostery blocks not just ads, but also the trackers. So you want an ad blocker and a tracking blocker, and you often find that your browsing experience is a lot faster because all of this extra code loading ads and tracking your every move on the internet is no longer running on your computer. So you can't really trust anybody. I mean, there is a private browser called Brave, and there are private search engines like DuckDuckGo, but even DuckDuckGo was accused of working with Bing and sending some information to them. So, there really does need to be some sort of a parallel internet where privacy is something that is advertised. Most likely you're going to have to pay for it. But if you don't pay and you're accessing service for free, then that famous saying is that, if you access a free product, then the product is you. It's your surfing behavior. So be very careful what you're searching for online, where you're searching. Use VPNs, use blocking software, tracking software, and even consider using a virtual machine. You can download VirtualBox on your PC, and you can run either copies of Windows or copies of Linux. Linux is free to use. It's an open source operating system. It's a lot of hassle to do all of this, but these are the sort of games we need to play in the modern era to preserve our privacy.
What about things like Tor?
Tor stands for the onion router, and it's also a way of surfing the internet, inverted commas, anonymously, but some of the endpoints that people use to jump from one jurisdiction to another, the endpoint is claimed to have been run by the CIA or other organizations that are then looking at what you're doing. If you're going to do that, I mean, normally people access Tor because they're trying to find things on the dark web. So whatever nasty things you can think of,
drugs, terrorism,
it's on the dark web,
and that sort of stuff.
Yeah, and how to create bombs and all sorts of things. It's all there. I personally have actually visited the dark web, but I've seen plenty of TV stories about it, and they talk about how you can hire hitmen, and even there was the famous Silk Road, which was a drugs marketplace, and eventually the guy that was running that got caught and still behind bars to this day. But if you're going to do that sort of thing, you need to run VPNs, and it's all a lot of trouble. I mean, there's more legitimate ways to make money than running around the dark web, but Tor is another way that people do use to try and stay anonymous online. But for every anonymous way, there's somebody else trying to figure out how to break through that encryption or break through to find out who you really are. They used to say that nobody on the internet knows you're a dog, but I bet some of these three-letter agencies know exactly who you are and what you're doing online. And sometimes you wonder why more people aren't being caught.
Now, there's a new story out about Facebook and Netflix having a bit of a get-together and swapping data.
Yes, well, there were claims on X that Facebook gave Netflix all your private messages on Messenger in exchange for all of your watch history, while Netflix paid them $100 million plus for ads. And the claim here is that Meta will sell your data at a heartbeat for profit. But Facebook or Meta spokesperson Andy Stone said, shockingly untrue. Meta didn't share people's private messages with Netflix. He says the agreement allowed people to message their friends on Facebook about what they were watching on Netflix directly from the Netflix app. Such agreements are commonplace in the industry. So, I mean, look, there's probably a grain of truth on both sides in the sense that, Facebook has been on a 20-year apology tour. They have been very fast and loose with our data and, of course, the Cambridge Analytica scandal. I mean, you see these things on Facebook that want you to put down information about what's your favorite color, and here's 31 numbers. Each number has a certain funny name. Each month of the year has another funny name. And if you put these two names together, you're going to be Indigo Starship or something. And they do that because they can then comb through that data. People just, oh yeah, I'm the thong-headed drongo, whatever the latest words are to go with that.
Starship was cool. I like that.
But they use that to then figure out what your date of birth is, your birth date and your birth month, for example. And they're able to collect all this information about you. And you think it's just some sort of silly, funny game, which for most people it is. But people are actually tracking what people are sharing on social media and then building profiles. Now, Google is meant to be doing this about what you're surfing online. Facebook's certainly meant to be doing it. And all these little tracking cookies across the internet are being used by different organizations, including the government, to build profiles on you. So again, that's why it's very important to use ad blocking software and use tracking blocking software so that your footprint on the internet is as small as you can possibly make it.
So there's a strong possibility people out there in the real world know that I've actually watched the Barbie movie.
The Barbie people probably do know that, yeah.
That's Alex Zaharov-Reutt from TechAdvice.Life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.